Hello friends, welcome to online engineering. As the title of the video suggests that in the today's lecture we are going to discuss about what is tension crack, how it is formed, what is the effect of tension crack and how the earth pressure varies, especially for the cohesive soil or for the C5 soil. To start, I am taking a soil that is C5 soil. So I am studying about the earth pressure in a C5 soil. But as we all know that the Rankine's earth pressure theory was applicable only for the cohesionless soil. That means to study the C5 soil having cohesion in it, we have to deal the whole procedure separately. And to start with, I am taking that the soil is an active soil. If the soil is an active soil, we already know that if we study the element of the soil, it will be subjected to a vertical stress sigma V dash and a horizontal stress equals to sigma H dash. In the active state, sigma H dash and sigma V dash, among these two, the vertical stress is more. That means we can say that the sigma V dash will be sigma 1 and sigma H dash will be sigma 3. We are here to calculate the lateral earth pressure acting on this particular active soil. So I am starting with the same equation that was used earlier, that is sigma 1 is equals to sigma 3 tan square theta plus 2c tan theta. I am taking the soil as C5 soil, that means neither C is 0 nor phi is 0. But the sigma 1 is nothing but that is vertical stress. That can be written as horizontal stress into tan square theta plus 2c tan theta. We are here to calculate the value of horizontal stress, hence I am taking the equation of horizontal stress, that is sigma H dash tan square theta on one side and on the other side it will be sigma V dash minus 2c tan theta. To calculate the equation for sigma H dash, we can divide it by tan square theta. So it will be equals to sigma V dash in upon tan square theta minus 2c tan theta upon tan square theta. It will be equals to sigma V dash into 1 by tan square theta minus 2c into 1 by tan theta. In the Rankine's theory, we studied that 1 by tan square theta is nothing but that is equals to 1 minus sin phi upon 1 plus sin phi, and that is nothing but that is your general Ka, that is the coefficient of active earth pressure. That means again here I can write this equation as this 1 by tan square theta will be Ka. So you can write it as Ka into sigma V dash minus 2c and 1 by tan theta will be nothing but that will be under root of Ka. So this will be the general equation for the horizontal stress acting in a C5 soil. But to study more about this particular equation, I am plotting the graph for a C5 soil for indicating the variation of earth pressure. Let us assume that this is the ground level for the given soil and there is no surcharge acting on this particular soil. Hence, we can say that the vertical effective stress at H equals to 0, as H is the depth, at H equals to 0, effective stress will be equals to 0 only. And hence, you can say that at H equals to 0, the value of horizontal stress will be equals to Ka into sigma V dash is 0 minus 2c under root of Ka. That means you can say that horizontal stress will be equals to minus 2c under root of Ka. Fine. If we are going downwards from the ground level, we know that at H equals to x, we can say that the vertical effective stress will be equals to gamma into x. and hence the horizontal stress will be equals to Ka into gamma into x minus 2c under root of K, and hence we can say that that horizontal stress will be a linear function of the depth, and with the depth, with the increase in the x, the value of horizontal stress is increasing. That means it will increase linearly, but if we are studying at a depth of h, then we can say that the horizontal stress will be equals to Ka gamma h minus 2c under root of K. If we are plotting this line as a zero level line, we can easily say that at the top horizontal stress was negative. So plotting values negative on this side and positive on this side, the line is indicating zero level. Then at the top, the earth pressure value is negative 2c under root of K. After that, the value of horizontal stress is increasing linearly. That means the graph will increase like this. And at any depth h, the value of horizontal stress will be given by Ka gamma h minus 2c under root of K. So this will be the variation of horizontal effective stress if we are studying about a C5 soil. But the question arises, what does this negative earth pressure means? What does this negative earth pressure signifies? So please listen carefully. I am describing you something very important. That what does this negative earth pressure signifies? So we have already studied that every soil have a tendency to spread itself. If a load is applied on the soil, its tendency to spread will increase. But this tendency is the general tendency. Hence, if the earth pressure is towards the retaining wall, that is away from the backfill, then such particular earth pressure is taken as positive. But if this is your retaining wall and the net force on the soil solids is towards the backfill, then such particular earth pressure will be taken as negative. So that is very simple, that earth pressure is negative means that the pressure is acting towards the soil. But why this is happening? It is very simple to understand if you are looking at your own body. For example, look at my face. The shape of my face is well maintained from last 10 days. Even if you are going to see me after 10 days, the shape will be same. That means even if there is a deformation or the net force in the outward direction, the skin will try to rebound itself. That means the net force on the skin of our body is inward. What will happen? What will happen if the net force on our skin or the body is outward? Then our body will try to move outward and the shape of our body will get deformed. But this is not the case with our body. That means our body can easily retain its shape. Any matter which is retaining its own shape, that means the net force on its surface is inward. That is helping it to maintain its shape. That means if the soil is C5 as we are studying, then that soil will be able to maintain its shape and will not try to spread itself. But is this correct for all the depths? No, because according to this particular diagram, we can see that the pressure is negative only up to some particular depth. After that, the pressure is positive. Fine. But as these negative and positive pressures are acting on the same soil, you can say that till a depth of this, the negative force and positive force will balance each other, and there will be a depth where both the negative and positive forces will get balanced. At that depth, the net force will be equals to 0. Let me describe it in more detail. Here we are going to determine at what depth this particular horizontal stress will be 0. I am taking this as condition that sigma h dash is equals to 0 at a depth of HC, and I am going to calculate the value of this depth HC by putting the value of HC in this particular equation. Sigma h dash is equals to 0, and at any depth the sigma h dash is given as k gamma hc minus 2c under root of Ka. Hence you can say that the Ka into gamma hc is equals to 2c under root of K. Hence hc can be written as 2c under root Ka upon Ka into gamma. Hence the value of hc can be again written as 2c upon gamma under root of Ka. This hc is nothing but that is the critical depth. But what does this critical depth signifies? Before describing this, I am describing you again a new depth. Then we will take both the depths together. But if this is hc, hence you can say that if a depth is lesser than hc, then earth pressure will be negative. If h is equals to hc, you can say that earth pressure is 0. But if h is greater than hc, you can say that earth pressure is positive, as it is mentioned in this particular diagram also, that if h is lesser than hc, it will be negative earth pressure. If the h is greater than hc, it will be positive earth pressure. But we can say that if the whole soil is a single body, then I am rubbing this particular part. If the whole soil is a single body, then this negative earth pressure force will be balanced by the positive earth pressure force. And we can say that net force will be equals to 0 if negative earth pressure area, because force is calculated by the earth pressure force area, is equals to positive earth pressure diagram area. So we are saying that if this area and this area should be equal, then the depth of negative area and depth of positive area should also be equal. That means we can say that summation of forces or net force on soil will be 0 at h equals to twice of hc. Why twice of hc? Because first hc is for the negative area and second hc is for the positive area to get balanced themselves. So we can say that at h equals to 2hc, the net force is equals to 0 on the soil. What will happen if h is lesser than 2hc? That means I can say that negative area will be greater than the positive area for this particular case. Why? Because if hc is lesser than 2hc, for example, this is a depth h which is lesser than 2hc, then in that case this negative area is greater than positive area, and hence net force will be negative. What does this negative force signifies? Negative force signifies that the net force is towards the backfill, not away from the backfill. Whereas if h is greater than 2hc, you can say that net force will be is away, or net force is outward from the backfill, that is towards the retaining wall. So the question arises that if the net force on the soil is inward, that means towards the soil, or the net force is negative, is there any requirement of any support to that particular soil? If the net force like that in the skin is inward, then there is no support required on the skin. But what will happen if the net force on our skin is outward? Like when we have some injury here, then in that particular case the net force on the skin will be outward, and to support this particular skin we have to provide some bandages, and those bandages are nothing but that are the supports given to our skin. Similarly, if the net force on the soil is outward or positive, then there will be a requirement of some support to maintain that soil its own shape. That means I can say that if H is greater than HC, then only the support will be required. Otherwise, if H is lesser than HC, in this case, no support will be required. No support will be required. That means I can say that this 2HC is the maximum depth of a cut which can sustain or retain its own shape. So this was our significance of the depth 2HC. 2HC is known as the maximum depth of unsupported vertical cut. Why it is known as maximum depth of unsupported vertical cut? Because there is no requirement of any support till the depth of the cut is less than 2HC. But when the depth of the soil is greater than 2HC, that net force will be positive and the net force will be outward. And in that particular case, if the depth of the vertical pit or cut is greater than 2HC, some support will be required. Hence, this depth of 2HC is known as maximum depth of unsupported vertical cut. I am writing down its name. This depth 2HC is known as maximum depth of unsupported vertical cut. Fine. Whereas if we look at HC, you can see here that if this is the level of HC, then this is your ground level, then above the HC the net earth pressure is in this direction, whereas below the HC earth pressure is in this direction. Above it is negative, below it is positive. You can see here that the earth pressure is negative above HC and positive below HC. What will happen if on a particular matter, on a particular plane, the direction of pressure changes? Look, I am giving you an example like of this particular paper. That is our paper. We can easily understand the concept. Let us take a paper and try to tear it. What you are going to? You are going to apply the force by one hand in this forward direction and by another hand in this backward direction. So this will be the action that will be for tearing this particular paper. And if we are applying that particular pressure, you can see that the paper will get cracked about this particular plane. That means you can easily say that if a plane is subjected to the change in the direction of pressure, then there are chances that some cracks will get formed on this particular plane. Therefore, we can say that at this HC, there are chances of the formation of cracks, and those cracks are because of the negative earth pressure. In soil, negative is the tension. Here, that is why the cracks formed are known as tension cracks. So what are tension cracks? Tension cracks are formed because of sudden change in the direction of the earth pressure. And this generally occurs at a depth where earth pressure becomes equals to 0, and that particular depth can be known as the depth of potential tension cracks. the depth HC where sigma H dash is equals to 0. This depth is known as depth of potential tension cracks. I hope you all understood this particular name, that tension cracks are because of the change in the direction of earth pressure, but it is said that it is potential because there are chances. It is not definite that the cracks will be formed always. There are chances that the cracks will be formed at this particular depth. Hence, the depth where earth pressure will become equal to 0, there are chances of the formation of cracks. Those cracks are known as tension cracks. So I hope you all got the concept behind the tension cracks, how the earth pressure varies in the C5 soil, or if the question is saying that the soil is purely cohesive. If the soil is purely cohesive, then we can say that the value of Ka, that is equals to 1 minus sine phi upon 1 plus sine phi. If the soil is purely cohesive, that means phi will be equals to 0, and phi equals to 0 means the value of this Ka will be equals to 1. That means for the purely cohesive soil, the formula will get slightly changed and the value of Ka is equals to 1 will be entered in the particular equation, and the formula for sigma H dash will be equals to sigma V dash minus 2C. Right. So this is a very simple formula for the purely cohesive soil. The value of K is 1, value of under root K is also 1. So you can easily calculate the equation for the purely cohesive soil, but it is generally not asked in the exams. Generally, C5 soil is more preferred because of some complex equation that is required to be solved. I hope you all understood this particular concept of the tension cracks. In the next video, we are going to understand about the effect of tension cracks. What will be the effect of the tension crack and how we can calculate the earth pressure force if the tension crack is developed or if it is not developed. So till then, लगातार पढ़ते रहे, बढ़ते रहे. Happy engineering.